There is perhaps no biological concept that draws more controversy than Darwin's original theory of evolution on the origin of species. The controversy breeds staunch supporters on both sides of the issue, mainly separated into the religious and science camps. As I said when we started this course, we cannot help but filter our ideas about the world through our own experiences. That is okay for some forms. It is not okay for science. Darwin's theory was based on his observations. Since then, many other scientists have made similar observations in many parts of the world, both in nature and in laboratories or on many different organisms. The observations, although as diverse as they are numerous, have been consistent in supporting much of Darwin's original hypotheses. Does this mean it's true? Does this mean that at some point in time our observations will lead to a different theory or a different hypothesis? Maybe, as that is the nature of science. So what about alternative explanations of how organisms came into being and how they have changed? Well, there are many. Perhaps the most prevalent and persistent is that life is the product of a supreme being, God, Jehovah, Allah, Zeus, or a variety of other names. There's nothing wrong with these belief systems. I have some very strong beliefs that define my religious, moral, and ethical thoughts. Yet, the basis of science is not believing, it is observing. If we cannot touch it, see it, smell it, taste it, or hear it, it's just not science. Remember though, science is not necessarily truth. It is our best explanation based on observation. Unfortunately, we did not observe the creation of the universe, the creation of the solar system, the earth, and the physical and biological products that inhabit the earth. Our science is limited by what we can deduce through our observations at the current time in our current place in the universe. So, as you have read about Lamarck and Wallace and Darwin and Mayer and the thousands of naturalists and scientists that have followed them, remember their observations are the best we have at this time and the best they had at their time. Also remember that you need to confine your responses in this course to the scientific explanation, not filtered through your personal beliefs. If you want to talk about creation and evolution in terms of belief systems, you need to do that in a different venue. We can explore other non-scientists' thoughts about these topics, and there are many other classes and other institutions that offer different approaches. You will not get credit for those discussions, however, in this class. Hardy and Weinberg simplified Darwin's and others' conclusions with a simple mathematical model. One of the case studies we look at for science is the Hardy-Weinberg formula, and we look at it in detail. But basically, Hardy-Weinberg says that without mutation, with no selective mating, with no immigration or emigration, in the absence of any selective advantage, and with a large enough population, organisms will not evolve. In other words, evolution changes in heritable attributes of organisms will only occur if there is a contribution of an individual that gives its offspring a reproductive advantage in future generations. Wow, that might be a little tough to understand. So, put it another way. If an individual contributes heritable characteristics to its offspring that allows more of those offspring to survive and reproduce than other individuals of the same species, the population of the species will change in the direction of the characteristics of that individual. In other words, this is Darwin's fitness, or what has commonly been referred to as survival of the fittest. Survival of the fittest has nothing to do with who is bigger or meaner or toughest. It is solely based on who can produce the most reproductively viable offspring, who themselves will survive to reproduction in the next generation. as mutation and sexual reproduction through the process of meiosis produces different phenotypic characteristics in offspring, some of those characteristics will provide the offspring with a reproductive advantage. Modern studies of evolution look at the various ways that reproductive advantage is expressed in populations. If the advantage is directional or diversifying species, speciation and extinction can occur. Although with species and extinction, along with species and extinction comes evolution. There is no doubt that a lot of organisms that were once on Earth are not around anymore. The fossil record is full of those examples. Some people still argue on how old the fossil record is, and therefore how old the Earth is. But without getting into that argument, there is no doubt that more species have gone extinct than there are species that are currently on the Earth. And our observations indicate that organisms that are currently on the Earth were not here at the time most of the extinct organisms were on the Earth. These observations lead us to the hypothesis that organisms are in constant flux, with some going extinct and others changing in ever so slight ways as to eventually producing life forms that look nothing like the original. In other words, living systems evolve. When I took my first biology class, scientists divided living things into two groups, plants and animals. These kingdoms were based on simple characteristics represented in all organisms in each of the groups. Now most biologists agree that there are at least 5 or more kingdoms in 3 different domains in the modern science of taxonomy. Taxonomy for our purposes is the naming and classifying of organisms into similar groups. Since the 1960s, cladistic analysis has taken over from traditional phylogenetic taxonomy, and old relationships between organisms are giving way to new genetic relationships. This is the nature of science. By the time you're as old as dirt as I am, it'll probably be different. What we can agree on, though, is old Carl Linnaeus's system of naming origins using what we call a binomial nomenclature. Bi for two, nomen for name, or what has come to be known as the two-naming system. Homo sapiens, homo, man, sapiens, wise. All organisms have 2 names, a scientific name which includes its genus and its species. Homo is the genus, sapiens is the species. The first letter of the genus is always capitalized. The first letter of the species is never capitalized. And both the genus and the species are in italics, or they are underlined. So Homo sapiens then in italics are underlined. I would like you to leave you with one thought about Darwin. The first edition of Darwin's original works on the origin of species ends with the phrase that newer versions leave out. The first edition of the book ends with this quote: "There is a grandeur in this view of life, with its several powers having been originally breathed by the Creator into a few forms, or into one, and that whilst this planet has gone cycling on according to the fixed law of gravity, from so simple a beginning, endless forms, most beautiful and most wonderful, have been and are being evolved." Darwin was a scientist. He also held strong religious and moral beliefs, breathed by the Creator, attested not to his science, but to his beliefs. Thank you. We'll see you again next time.